So for the test review he gave us, um, it says vocabulary, but down here it says it's just a joke, so we kind of ignore it, and I didn't see anything like that on the test. So up next, we get to this, be able to construct a confidence interval, which is very interesting because none of the problems he has on here really has a confidence interval, but he does say we should be able to do it. And I don't quite remember what was on the test, but I'm pretty sure it'd be not hard to just go over it again. So a confidence interval is just anything that has interval after it. Just a reminder. All of these count, but not that. But anything that has like this int after it. But because this is over t-tests, we don't use any z intervals. So all that was really important is number 8 here, the t interval, and this one right here, 0, 2 sample t interval. Those are the only two you'd have to use if you had to use them at all. And so then on to the second part. It says complete hypothesis testing. The following using the inappropriate hypothesis test. Use the null hypothesis, alternative hypothesis, test statistic, which is just these numbers right here, and then conclusion, whether we accept or reject it. And so to start, we're going to just go with number 1, I guess. And I'm going to really just point out this test statistic here, which is 86%. So you have this 86%. And what that percent tells me right off the bat is that this is a proportion. This is basically, this could be rewritten as 86 over 100. And the thing about proportions is if you look in your calculator, if you turn it back on, you go to statistics and you go to tests, you're going to see that the only thing that has proportion attached to the test name is going to be z-tests. And this holds all the way through. So you cannot have a t-test and a proportion. So if you ever see a proportion that's like where you're given like a number like 86% or this many things out of this many things, that is going to tell you right away that you're going to be using a z-test. But more important than that is that you don't get this confused with that. This is a confidence level. This does not count towards proportions. This is something else. This is going to be, if you open up a test, so for example, if I go back to stats test, if I open up let's do, I think, nope, sorry, wasn't prepared for that one, but I think if you go somewhere like here, no, still no, oh well, I think it might be over. No, all right. Well, it'll say confidence level or like alpha level or something like that, and that's where this comes in. Not in terms of, this is only this matters for proportions. And like I said, it's going to be that something out of something, or like the normal rate is 86%. So we're like something is normal. And then you move on to the next important numbers, which is going to be this 1,248 and this 1,356. And this is also a proportion. It's going to look like something like this. So this many passed out of this many total. And so what you're going to do now that you know all this, so you know it's a proportion, so you know it's going to be a prop. And you only really have one proportion. You only have one number here. So it's going to be a 1 prop, and we know it's going to be a z-test. So if we find that on our calculator, we go on stats, tests. Hey, would you look at that? 1 prop z-test. 5. Let's click on it. So you get this p0, which is what this number is. This is our normal rate, or what we're comparing it to. So we're going to put this in, we're going to put this in as at 86%. So we're going to say 0.86. Then we're going to go down to the next number. This is going to be x, or the number of successes out of our number of failures, which is going to be that 1248. 1, 2, 4, 8. Then we're going to go down. This is our n, or total number of trials, which is going to be our denominator, which is going to be 13, 5, 6, or our out of. That's also important phrasing. That tells you what's on the n. And then what we're looking for, because we don't really know which one of these it is yet, but if you look at the wording, you're going to see significantly greater than, right? So now we know the test. We know that we're looking for our h naught is basically, I have to do these first, but basically we're looking to see if our proportion here, so our proportion is going to be p1, we're going to see if it's greater than that P naught. That's our hypothesis. But our null, or basically if we're wrong, we're going to say, hey, maybe these aren't different at all. Maybe these are exactly equal. So that's how you figure out this. H naught is, or H null is always going to be no difference. While the HA is always going to be like greater than, less than, or not equal to. In this case, it's going to be a greater than, sorry. And so what you're going to do is then you're going to say, hey, our number is going to be greater than P naught. As you can see, face is open, and the triangle part is facing towards the P naught. Same as on here. So we're going to calculate that, and we get a z-score of 6.40. And I guess we could go on, like let's say 6.405. Let's do that. And we're going to get a p-score of 7.55. And I'm going to point out right here, times e to the negative 11. So this is basically times 10 to the negative 11. Which what that means is this is basically the equivalent of 0.1234, 11 zeros, till you get to this number right here, 7550987. So there's going to be a lot of zeros. So this p-value is really low, and our z-value is really high. So because of these two things, and if I want to point out that this number right here, this p-value, is less than our, so we have a 95% confidence level, so that means we're going to have an alpha level of 0.05. Our p-value is way lower than this alpha level. Way, way, way lower. And so that's how we know that we are able to reject the null. And so, since we can reject the null, we know that based off of this test, the proportion of vehicles passing their emissions test at this substation is greater than the established rate. I'm not going to write that down, but if it ever said to like interpret what this means, that's what it means. Is it means that your alternative, so the proportion of things that pass in this situation, the things that pass, is greater than the established rate. All right, on to the next one. We get to number 2. We have another out of, which is going to be another proportion. So that's 426 out of 620. So hey, we know this is a proportion. And we know 95 confidence level, that's important. This is our alpha level. Then we get to this number right here. This is going to be what this number was for us. So we're going to have our P naught equals 68, or our P null. And so this means that our H null, or our null hypothesis, is going to be, hey, this proportion is equal to that percentage. So we're going to say P1 equals P0, or P1 equals 68%. However, our alternative hypothesis, HA, says that you see how there's no significant wording here where it's like, the only thing we really get to is equal to here. So we don't know greater than or less than. So this is where we're going to default to P1 does not equal P0. So that means P1 doesn't equal 68%. And it's going to be really important where wording is super important to tell us what our alternative hypothesis is, just because based off of what it says in the word problem, that's how we know what to put into our calculator. So now that we have all of this, we're because we know it's a proportion and there's only one proportion, we're going to once again do a one proportion z-test, or a one prop z-test. And it's really, really important to be able to identify these. So if you see a proportion, it's a z-test, depending on how many proportions there are, or is there just a regular one and a single, whatever this is called. So is there basically a base proportion and the test proportion? Then you're going to use a one prop. But if you have two test proportions, you're going to use a two prop. So once again, proportion is always going to be z-tests, and that's important. We will move on to t-tests on the other side, I believe. And so what we're going to do, we're going to go once again to stat. We're going to go over tests. We're going to scroll down to one proportion z-test, which is number 5 again. And we're going to put in a new numbers. So it's going to be 68. Oh, oops, I typed that in wrong. We go down, we're going to do 426, and then over 620. And then this time, for our what our proportion thing is going to do, we're going to do not equal to p0, p naught. So our test proportion is not going to equal the regular proportion. And if we calculate, we get a z-score of 0.3788 and a p-score of 0.7048. So I want to point out that this is kind of low, and this is really high. And since we have a 95% confidence level, we know our alpha level is 0.05, and 0.0748 is not less than 0.05. Like, that isn't true. And so what we're going to do here, since that isn't true, we know that we can't reject our null. Sorry, I put it off screen. We can't reject this. So we're going to say our null. So we fail to reject null. So this one, we're saying that this proportion does in fact equal this proportion. So we've proved it. We're right. Okay. Now we move on to the backside. We're going to flip it over. And this is where hypothesis testing regarding one sample and two samples, which is going to be very interesting, very fun, I should say. So for this one, number 1, it's going to be kind of interesting. So right off the bat, 40-meter dash, but that's just describing something. $200 fee might be important. Keep going, keep going. Hey, sample, that's important. 120 with a mean. This mean applies to this right here. With a 0.6 second standard deviation. Sorry, I underlined it that bad, but yes, this. And then we get to, hey, 112, another sample, new group, with a 5.7 mean and a 0.4 standard deviation. So you have all these numbers, and it's like, oh, hey, we have 2 sets of something. We have 2 ends, because 120 and 112. We have 2 means, we have 2 x bars of 5.9 and 5.7, and we have 2 standard deviations. And so this is going to be a 2 something, because we have 2 of everything. And so this is really intriguing that we have a sample of, and that this isn't a proportion. Because if we have a sample of something, and it isn't a proportion, we can assume that it might be a t-test. So we have a to sample t-test. So if we go to stats, tests, to sample t-test, right there. And you're going to be like, how do we know it's not a z-test? A z-test has proportion or population standard deviations. We have sample standard deviations. That is going to be the major difference. So we're going to do a 2-sample t-test because we have samples. So that's what we're going to plug all this in. So we have our first mean is going to be our 5.9. And our first standard deviation is going to be 0.6. Can you see this? Yes, you can. Perfect. Then our first number was 120. Our first number of, like, sample number. I guess that makes sense. Like, number of things in the sample. There we go. So then we're going to move on to our second one, which is going to be 5.7. And then we're going to get to a 0.4. So 0.4 standard deviation. And our second number was 112. So we have all that plugged in, but we don't really know what we're doing with it yet. So our H null, of course, is going to be that these two are equal, right? So our X bar and our Y bar are the same. So our means and their standard deviations, there's no difference. They're the exact same thing. Our alternative is that they are different. And since we have an athletic coach claiming she can improve, we're going to say that X bar is going to be greater than Y bar. And I know this is a little confusing for me. I don't know if it's confusing for you, but I wrote it that way on purpose. Just know that. So what we're going to do is we're going to look at this. We're going to scroll down. We're going to say, hey, this kind of looks like we wrote down, doesn't it? Yeah. And pooled, always leave that as no. We are never going to do anything pooled. Never. Okay? So that is always going to be no. So I'm going to calculate this. And hey, if you look at that, we have a t-score of 3.005. And we have, sorry, that's a little high. We have a p-value of 0.0015, basically. We're just going to round it. So, as you can see, with our 95 level of confidence and our alpha of 0.05, this is less than that. So this is low. And this, 3 standard deviations, that's pretty high. So we're going to say reject the null. And so, okay, based on the information, use the appropriate test. Yep. Identify the null and alternative. Yep. The level of significance. Yep. And any issues or bias. So I guess what could happen here is maybe it's like who was running, so it's senior athletes versus just athletes. We don't know. But just little things where you can point out, hey, I guess someone could be upset about this. You can kind of just make stuff up. Doesn't really, not too important. Our next question. So that's going to be the answer to this one. It's just reject the null. Just that's going to be your major thing, and then you can elaborate based off of that. And then you're going to maybe want to also talk about errors. Sorry, I forgot to discuss errors. But if you remember errors from last time, a type 1 is where you reject the null, but there's a chance that the null was true, in which case that could be a possible type 1 error, and those are bad. We don't want to make those. But since this is really low, and this isn't terribly super duper low, but it is pretty low, and this is pretty high, so we have a higher chance of making a type 1 error, but it's still not very high, if that makes sense. And then type 2 error is where if you fail to reject the null, so you're keeping a null hypothesis, but that hypothesis is false. So it's basically, hey, this could be wrong, but our test doesn't have enough evidence to show that it is, so we're going to keep it for now. And so that's what a type 2 error is. So sometimes he'll ask for that in your interpretation of rejecting the null. Okay, on to the next one now. A group of 15, that's just, I always like noting numbers that are important, even if I don't need to. And we're given basically 2 lists. Now it's really important you make these lists in orders, or you put these lists in order, because we're using before and after results. So that means all of these are paired. So you need to keep them in the exact same order. So you need to type it in from left to right on both of these. So this one's going to be an L1, this one's going to be an L2. And I've already typed those in because I didn't want to force you to just sit here and watch me do it. But you're going to type all of these in. Ignore L3 for now. But you're going to type all of these in, and you're going to make sure they're coordinated with their pair. So basically, this one is row 8. 64 is still with 67. So that's all you need to know, is just keep them in pairs. Because in order to identify our H null and our HA, we're looking for, I believe it's improvements. Let's see. Oh yeah, whether it was effective in increasing their knowledge of diabetes. So how do we test that? Well, we're going to subtract these. So we're going to say that our knowledge of the diabetes after the test minus our knowledge of diabetes before the test is going to be 0. Basically, there is no difference. The whatever program they ran through and the test they did, basically it didn't do anything. That's our null. Always our null is going to be no difference. But our alternative is, hey, our mean after they took the test, subtracting their mean before they took the test, is going to be more than 0. It's going to be greater than 0. They show some improvement. And so this is where the greater than is basically the improved. That's what it tells us. Or I spelled that wrong, sorry. The improved. So we know that we're looking for something greater than. So if you type in both those lists, what you can do is you can say, hey, what if I take L1? Or no, actually it's going to be L2. Crap. L2, because this is our after. we're going to subtract our L1. So it's L2 minus L1. You're going to get a whole new string of numbers. You're going to store that into list 3. And so now you have this new list done. And this just makes it really easy because now when you go to stats and tests, and you go down to a t-test, and this is a t-test because it's a group of 15, so it cannot be a population, so it has to be a sample. So we know that since it's a sample, we're going to use a t-test. So we use a t-test, and if you scroll this on over to data, you can use lists. And our U0 in this case, this thing, 0. We just want to see if it changed at all. And now, all of our numbers are in list 3. We don't need to change this. And hey, we're looking for it's greater than 0. So yes, we can click calculate. And it gives us our t-score of, 4.002. And our p-value of 6.55 times 10 to the negative 4th. So that's going to be basically 1, 2, 3, 4, 6, 5, 5. So once again, really small, way less than our 98 point. So this is going to be a 0.02 alpha, but this is way less than that. So on both accounts, we reject the null. But I want to show you why I moved everything to list 3 first. So basically what you can do is you can just say, hey, L2 minus L1, what is that? I do recommend putting into list 3 because then you can go to stats, 1 var stats, list 3, calculate, and you can see your mean and your standard deviation. And then you go back to the test and you go to your t-test. And let's say we didn't do data. Let's say we did stats. Hey, we needed that mean and standard deviation and the number of things. And so just putting it in list 3 makes it really easy so you don't have to type all this in and you just really know what's going on at all points in time. So that's why I did that. It just makes it a lot easier, a lot simpler. And so then we reject it, and then any bias or concerns with the results, I guess you could say maybe the questions changed, maybe the questions didn't change, maybe the group, I don't know, just stuff like that where it's like, hey, maybe something happened, or maybe they knew more and they were just told to pretend dumb, or they weren't given time to study or something like that. I don't know. But little things like that. And so these two are t-tests. And so this one is this is just a blank t-test. And this one was a 2 sample t-test. And so it's really just important to look at what you have. So in this case, we had 2 of everything. In this case, we had what looked like 2 of everything, but we could, based off of the test we had to do, we had to show an improvement, which means we had to compare the 2, which means we really only had 1. And so that means we got to use just a t-test because we were doing a comparison and we had a rate to compare it to. This is our, like, not a rate, it's a score, I guess. I guess would be a better word, is like a score to compare it to. And so just keeping your eye out for things like this is going to really help you with identifying what kind of tests you have to use, because he doesn't tell you on the test. He doesn't tell you, so you have to figure it out for yourself. He didn't give us the answers for this one, and I am too uncertain about going over this one with you or without the answers. But in this one, I can do. But once again, you're going to see, hey, 36 out of 53, 15 out of 26. That's proportions. And there's 2 of them. So it's going to be a 2 proportion z-test. And I mean, I'll go over it just in case, but this is less important. And so you do all this, you do get 95 level of confidence. You're going to open up, you're going to set up your hypothesis first. Sorry, I keep forgetting to do that. So, hey, this is these with a roof closed and this is with a roof open. So we're going to say our proportion with the roof closed is equal to the proportion with the roof open. And then we're going to say, hey, no, wait, our proportion with the roof closed winds at home is higher with a closed roof is greater than basically with an open roof. So this is what the higher came from. So closed roof, proportion closed, is higher than open roof, proportion open. That's where I got that from. So those are our hypotheses. I don't know the plural of that. But you can go into stats, tests. This is going to be a two proportion Z test, specifically Z, that one, 5, or no, 6, sorry, 6. And you're going to see, hey, we have 36 divided by 53, and then 15 divided by 26. And our goal is P1 is greater than P0. So in this case, or P1 is better than P2 in this case. And then we go calculate. And hey, look at that. Low Z-score. Not terribly, like higher than the confidence level. So the alpha of 0.05, that number, that p-value is not less than that. So in both cases, we fail to reject null. So basically, in this case, closed roof, open roof, it doesn't really matter. It doesn't affect their wins. And so you can interpret that basically saying, yeah, because of this test, we know that proportion between the two isn't any different, not statistically significantly different, if that makes sense. And you could say we're making a type 2 error because we failed to reject the null, but the null could be false, but we don't know that for sure. And so that's where a possible type 2 error comes in. But overall, it's a fail to reject. And then I can't do this fourth one with you because I don't know how to do it. But I really hope this is helpful. Once again, I really, really have to emphasize the importance of, sorry, I'm looking over the answer key right now just to make sure I got these numbers right. But really, 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 really important that you are able to identify what kind of test you're doing. So just honestly, on the test, I'm not going to lie. I just went to the tests, like over here, and I was just like, do I have you? Do I have you? Do I have you? Nope. Do I have any of y'all? Oh, hey, I have all of them. Or, no, I have extra, so I'm going to go down to a different t-test like this one. And hey, maybe this one fits everything I need. But just, the calculator is so helpful. It'll tell you what you need to plug in. Honestly, just looking at the calculator, seeing what kind of tests you need to perform and like what you have, what's given to you in the equation, it's all pretty open. You're not going to need to do any complicated formulas. I think this is going to be the most complicated one there is, but both times it shows up, it's a list. So just know that if you see a list, this is going to be the most complicated one to identify, and I think it's just a t-test. So I really hope this helps. I hope it makes sense, and you got this.